Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about trigonometry. Now the question that I've chosen to go through here is 2019 Paper 2 Question 9. In this question, at the start of it, we're given a lot of information about a ship and a radar detection within a circle. Not relevant to Part A. In Part A, the only thing that is relevant is the triangle ORQP, which is given and labelled as Figure 2. We know that ORQ is a 90 degree, and ORQP is a 90 degree angle, that ORPQ is a 30 degree angle, and that the distance ORP is 120 kilometers. With this in mind, we're asked to find the distance ORQ, which will be the radius of the circle. Now you should realise we're dealing with a right angle triangle, which means we're dealing with junior cert trigonometry. We know the angle 30 degrees, we're looking for the opposite, and we know the hypotenuse. If we're dealing with the opposite and the hypotenuse, we're dealing with sine. So because I know that the sine of an angle, or in this case the sine of 30, is equal to the opposite, which in this case is the distance ORQ, over the hypotenuse, which in this case is 120 kilometers. So sine 30 is opposite over hypotenuse. Once we've written this equation, we've got one unknown, so we can find ORQ. You could view this as sine 30 over 1 and ORQ over 120. So depending on which way you're more comfortable with, you could cross multiply, or you could just multiply both sides by 120. Either way, the end result is the same. If you multiply both sides by 120 or you cross multiply, you get 120 times the sine of 30 is equal to the distance ORQ. And if you plug all of this into your calculator, 120 times sine 30 gives me 60. And remember, the 120 was in kilometers, so obviously this is in kilometers as well. The distance ORQ is 60 kilometers, and that's your final answer for Part A. In the second part of this question, we're now given a different diagram. We're dealing with the triangle ORQS. We're told that the distance ORS is 100 kilometers. We're asked to use our answer to Part A. So the answer in Part A was that QOR is 60 kilometers. And we're asked to use this answer in order to find the distance from Q to S. So remember that this is a right angle triangle. I know that the angle here is 90 degrees, and I know two sides in the right angle triangle. If you know two sides in a right angle triangle, in order to find the third side, you have to use Pythagoras Theorem. Pythagoras Theorem can be found in the maths tables, and it's a squared is equal to b squared plus c squared, where a is the hypotenuse of the triangle. In other words, a has to be the longest side in the triangle, which is the one opposite the 90 degree angle. The side opposite the 90 degree angle in this case is 100. So that means my a has to be 100, and then b and c, it doesn't matter which is which. So I've labelled the 60 kilometers as b, and then the c is my unknown, the qs to be squared. So in this case, I have 100 squared is equal to 60 squared plus qs, the distance qs to be squared. 100 squared is 10,000, 60 squared is 3,600, and then qs to be squared, obviously there's nothing I can do with that. Then I subtract 3,600 from both sides. I get 10,000 minus 3,600 is equal to the distance qs to be squared. 10,000 minus 3,600 is 6,400. And I still have the distance qs to be squared. But obviously I don't want it squared, I want just qs on its own. So to get to the last line, I just get the square root of both sides, which means that qs is equal to, the square root is 6,400, which is 80 kilometers. And that's your final answer in this case. Okay, in Part C, I've been asked to find the distance QP. In order to find the distance QP, we need to consider this triangle, the triangle ORQP. Okay, I know that ORQ is 60 kilometers. I know that ORP is 120 kilometers. Remember, in the previous part of the question, we worked out that QS is 80 kilometers. So what I want to do in this question is I want to find the distance from Q to P. Because if I can find the distance from Q to P and then subtract 80, I'd just be left with this bit, which is the distance PS. So obviously, the real point of this question is just to find the distance QP. If you look at the diagram I've drawn here, we have a right angle triangle. We know two sides in the right angle triangle, which means we just use Pythagoras Theorem and we find the third side. So it's very similar to the previous part. I'm just using the formula for Pythagoras Theorem, a squared equals b squared plus c squared, where a is the longest side, or in other words the hypotenuse, which is opposite the right angle. So opposite the right angle in this case is 120. So I can say that 120 squared plus 60 squared, 120 squared is equal to 60 squared plus qp to be squared. When you work this one out, you just work your way through the question, and qp, the distance qp ends up as 103.923. In other words, the distance from q the whole way to p is this. Now remember, this question asked me to find the distance ps. And in the previous part of the question, we worked out that the distance from q to s was 80 kilometers. And now we know that the distance from q to p is 103.923 kilometers. So obviously, if I just subtract 80 kilometers from this value, I'll get the distance ps. So 103.923 minus 80 kilometers means that I'm left with ps, and that works out as 23.923. However, the question asked me to leave it to the nearest kilometer, so obviously in this case I need to round up. And my final answer here, I can say that the distance ps, if you round that one up, it's 24 kilometers. In D part 1 of this question, we're asked to consider the triangle ORST. And we're asked to use the cosine rule to find an expression for the cos of theta, where theta is the angle TORS. We're then asked to hence prove that theta is equal to 106 degrees. So the first thing that needs to come into your head is they've asked me to use the cosine rule. So if you go to your maths tables on page 16, you can find the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a. The small letters a, b and c represents the sides of the triangle. The capital A represents the angle. So clearly the angle we're talking about here is the angle theta, which means that the side opposite it will be the side A. That's going to be what I sub in for my small a. Then this will be my B and this will be my C. It really doesn't matter which is B or which is C. Now we've got an obvious problem here. We're trying to find the angle. We're trying to prove that that angle is 106 degrees. But if you look at this formula, in order to find an angle, you need to know the three sides of the triangle. You need to know all three sides. It appears from this diagram that we only know two sides. But I want you to look back at what we've done previously, because we actually know the distance ST. On the original diagram, they've drawn in this line, and they've marked this point here as Q. You should know from your geometry that if you draw a line from the center of a circle to a chord, if it's perpendicular to it, then that means it bisects the chord. So I know that Q is halfway between S and T. And in a previous part of this question, we worked out that SQ is 80 kilometers. The distance from S to Q is 80. And if Q has to be halfway between them, if I just multiply 80 by 2, that means the distance from S to T must be 160 kilometers. 80 multiplied by 2 gives me 160. So based on that logic from our geometry, I actually know that this side is 160 kilometers. And once I have that, this question becomes a lot easier. I know that A, the small a, is 160. I know that B is 100. I know that C is 100. Which means if I sub into this, the only thing I don't know is the capital A, or in other words, the angle. So let's just use this formula and we can manipulate it to find an expression for cos theta and then prove that theta is 106 degrees. So from our diagram, we've identified that the small a is 160, small b is 100, small c is 100. And we need to use the cosine rule in order to find the angle. Now, if you're using the cosine rule in order to find the angle, the easiest way to do it is actually to manipulate the formula before you sub in. So you'll notice here that I didn't sub in on the next line. What I want to do is I want to isolate this term on the right hand side. I want to isolate cos A before I sub in. So what I did was I brought the b squared across and it became negative. I brought the c squared across and it became negative. So now I have a squared minus b squared minus c squared is equal to minus 2bc cos A. I want to get cos A on its own entirely, so I need to divide both sides by minus 2bc. In other words, you just manipulate the formula and you end up with cos A is equal to a squared minus b squared minus c squared over minus 2bc. And this is going to make my life a lot easier. I have rewritten the formula from my log tables. I've just rearranged it so that the cos of the angle is on its own. Now, it's on the next line that I sub in. Instead of A, I can put in 160. Instead of B, I can put in 100. Instead of C, I can put in 100. So I do that on the top and the bottom, and on the right, I write this as cos theta. Now, all you have to do then on the left-hand side is just plug all of this into your calculator, and when you do, you get minus 7 over 25. Notice that in D part 1, it asked you for two things. The first thing it asked you to do was find an expression for cos theta, which means this is your first answer. Cos theta is minus 7 over 25. It actually specifically asked you for that, so there's marks going for that line. You have to actually write down that line. If cos theta is equal to minus 7 over 25, now the next bit I have to prove that theta is 106 degrees. So I need to bring the cos to the other side. It becomes cos inverse of minus 7 over 25. And if you plug that into your calculator, once your calculator is in degrees, your answer works out as theta is equal to 106 degrees. In D part 2 of this question, we're told that John sails directly from S to T. And from previous parts of this question, I know that the distance straight from S to T is 160 kilometers. On the other hand, we're told that Mary sails along the minor arc from S to T, which is, in other words, along the edge of the circle from S to T. Because it said minor arc, I know it's this way rather than that way. If it said major arc, I might be looking at the larger one, but the minor arc is this way. And I'm asked to calculate the difference between the distances travelled. So obviously the point of this is I need to find the distance Mary travelled and the distance John travelled and subtract them from each other. I already know that John travelled 160 kilometres, so that's not going to be an issue. The more difficult thing is working out how far did Mary travel. If you go to your maths tables on page 9, there's a formula that allows you to calculate the circumference or the perimeter of just a small section of a circle. Clearly we're dealing with degrees here because my angle is in degrees, so we'll use the formula that the circumference of an arc is 2 by pi by or by theta over 360, where theta is the angle in the centre of the arc and or is the radius of the circle. I know the radius of the circle is 100 kilometers, and from D part 1 we worked out that the angle at the centre of the arc is 106 degrees. So if we just plug all of that into our calculator, we work out that Mary travelled 185 kilometers. So to work out the difference between the distances travelled, it's just 185, which is Mary's distance, minus 160, which was John's distance. So it means that because Mary went the long way, she travelled an extra 25 kilometers. In the final part of this question, we're dealing with the region or ST again. And we're told that on average, there's one ship per every 25 kilometers squared within this region. So within this region, there's tends to be one ship for every 25 kilometers squared. Now the first thing that should come into your head is that they're talking about kilometers squared, which means they're clearly talking about area. So first thing I need to do is work out the area of this region. So once you've identified that, you go to your maths tables on page 9. Alongside the formula that we used in D part 2, there's a formula to get the area of a region or the area of a sector of a circle. The formula to get the area of a sector of a circle is pi times r squared times theta over 360, where theta is the angle at the centre of the sector and r is the radius. So if I just sub in 106 for the theta and 100 for the radius, the area or ST works out as 9,250.25 kilometers squared. So this is how many square kilometers exist within the region or ST. And on average, there's one ship per every 25 square kilometers. So I can use this information to calculate or estimate the number of ships that I would expect to be in this region at any one time. If I just divide 25 square kilometers into this, I get 370. So that means that at any one time I would expect there to be about 370 ships within this region. And that's your final answer for the last part of this question. So I hope all of that makes sense. If there's anything you're unclear on there, send me an email or let me know in class and I'll explain it differently.